Good morning dear students. Okay, I am your physics lecturer. Myself Shweta Prabhu. I am going to start the topic motion in a plane. It's a 12-hour topic. For the annual exam it carries nearly 13 to 14 marks. Okay. So here motion in a plane. Okay. Motion means somewhat object is in movement or change in position. Before going into exact concept that is regarding the motion in a plane, we have to use certain concepts that I am going to explain in the today's class. Okay, you know the term mass, length, time, temperature. Okay, this term is nothing but physical quantities. Here terms again ಹೇಳ್ತೇವೆ ನಾವು physical quantities ಅಂತ ಹೇಳ್ತೇವೆ. Okay, so physical quantity is a quantity which can be measurable. Okay, accurately ಏನು ಮಾಡಬಹುದು, measure ಮಾಡುವಂತದ್ದು. Okay, so there are various type of physical quantities. Okay, so here in this topic we are going to use the type, that is physical quantity, that can be classified into two types depending upon the magnitude and direction. Okay, physical quantities so we can define the term a quantity which can be measured. Okay, measurable quantity is nothing but a physical quantity. Okay, so depending upon the magnitude and direction, we are going to classify the physical quantities in two types, that is scalars and vectors. Okay, scalars, vectors. Okay, here actually physical quantity two types, that is fundamental physical quantity and derived physical quantity. The fundamental quantities will be scalars and derived physical quantities will be vectors, which will come to know in unit and measurements topic. Okay, scalars, a physical quantity. Scalar is a physical quantity having only magnitude. quantity having both magnitude and direction. Magnitude and direction. Okay. So first I will say one example. Initially this resistor is in the rest condition. Okay. So I have to move this resistor in the upward direction. I have to move this resistor in the upward direction, that is towards north. Okay. So what happens, in order to move this resistor, what I have to do? I have to apply certain force in north direction. I have to apply certain force in the north direction. Okay. I will show you here. Okay, there is one block here, one object. Okay. Next, this object should be moved in the north direction. I will consider an example. I will apply the force of 5 Newton due north. Okay. So what it indicates here, I am going to apply the force to this block of 5 Newton. Okay. 5 is the magnitude, N is the unit, due north means I am moving this block towards the north direction. Moving this block towards the north direction. Okay. The example for this is that is displacement next velocity acceleration force torque angular momentum. There are several quantities. Okay, few of them: displacement, velocity, acceleration, force, etc. Okay, so we cannot add the vector quantities by a algebraic method. We cannot add this with the algebraic method. Okay, there is one more method by which we can operate the vectors, either addition or subtraction. That method is with the help of a graphical method. Okay, for that we should know how to represent the vector. There is one representation for a vector quantity. I am going to say about that. So the representation of a vector. Representation of a vector. Okay. So scalar ಗೆ notation ಇಲ್ಲ. So ಅದೇ ತರ vector scalar ಅಲ್ಲ vector ಇಂದ differentiation ಮಾಡಲಿಕ್ಕೆ notation ಇದೆ. That is, you should draw straight line segment. Okay, one straight line ಅನ್ನು draw ಮಾಡಿ. Next, it ends with straight line segment indicates the magnitude of a quantity. It gives you what? Magnitude value. Okay, magnitude value. And the arrow mark, this arrow mark gives you what? Or the arrowhead indicates what? Direction of a vector quantity. Okay, straight line segment gives you the magnitude and arrowhead gives you the direction of the quantity. Okay, so that is how we represent this vector. I can write the value vector here. For example, A is a vector. I can write vector A is equal to OP vector. Vector A is equal to OP vector. Okay. Next, I can express this magnitude value or the straight line segment value in terms of modulus sign. That is, mod of vector A gives you the magnitude. Modulus of vector A, modulus of vector A gives you what? Magnitude. Okay, modulus of the vector gives you a magnitude of a vector A. Okay, or if you apply this mod sign, simply you can write letter A. Okay, if you apply the magnitude or the modulus value here, simply you can replace this term by A. Okay, next, there are various types of vectors, okay, which you are going to study. Okay, so that is null vector, which is also called as zero vector, then equal vector, unequal vector, negative of a vector, various types. Let's study one by one. Okay, types of vectors. Types of vectors. In the first one type, null or zero vector. Null or a zero vector. Okay, the given vector is said to be zero or a null vector if the magnitude is zero. If magnitude is zero, such type of vector is called as what? Null or a zero vector. So nothing but what we can say, initial point and the final point. Okay, initial point and the end point both are at the same single point. Okay, then only null vector or a zero vector arise. For example, if person ride a bicycle in a circular path, comes to its initial position. So it covers a complete one circular path. Its initial point and the final point both are same. In such case, that is in circular motion manner, if both initial point and final point are same, such type of vector is called as null vector or a zero vector, usually represented with O, vector O, or we can also represent it in terms of A vector, which indicates initial point and final point are same. Okay, next, equal vector. Equal vectors. Okay, so when we can say the vector as equal ಅಂತ ಹೇಳಬೇಕಿದ್ರೆ there should be some comparison. Compare ಮಾಡಿದ್ರೆ quantities ಬೇಕು A, B, C, D. Okay. A, vector A, and CD represents vector B. A, vector A, CD represents vector B. Okay. So in this diagram, the magnitude value, the line segment value is same. Okay. And direction is also same. Both magnitude and direction should be same. Okay. If you see this diagram, AB is equal to CD. Here vector A represents vector AB and vector B represents vector CD. So magnitude is same, direction is also same. Then we can write vector A is equal to vector B. Two vectors are equal. Okay. Such type of vector is called as what? Equal vectors. Okay. Next, one more type of a vector. Unit vector. Okay. Unit vector. Okay. If magnitude is of unity or magnitude is 1, then that vector is called as what? Unit vector. If magnitude is unity or 1, such type of vector is called as unit vector. Suppose, for example, A is a vector. We have to find out the unit vector. So there is a notation, that is for vector A cap is the unit vector. For vector A cap is the unit vector. We can also represent this vector in terms of unit vector notation. Okay, vectors in terms of unit vector notation, that is vector A modulus of vector A into A cap. Vector A equal to modulus of vector A into A cap. Here vector A, this value represents what? Magnitude value. This unit vector represents what? Direction. If magnitude is other than unit A, so this value helps to represent the direction. Especially in a Cartesian coordinate system, when we are going to represent the motion of a particle in a with respect to x-axis, y-axis or a z-axis, in order to say the direction, we are not going to say x direction, y direction or a z direction. Instead of that, we are going to use the notation, unit vector notation, that is I cap, j cap, k cap. Okay. Here I cap represents the direction of the vector along x-axis. J cap represents the direction motion of the particle along y-axis, and k cap represents the motion of the particle along z-axis. Since the Cartesian system x, y, z are mutually perpendicular to each other, nothing but 90 negative of a vector. So negative ಅಂತ ಹೇಳಬೇಕು ಅಂದ್ರೆ there should be one more vector in order to compare the vector. Okay. So if one vector is positive, vector A, one more vector I will consider, representation is same, but I will consider as minus B. So minus B, what it indicates? given vector quantity. So direction ಅನ್ನು ಹೇಗೆ ಚೂಸ್ ಮಾಡ್ತೇವೆ ಇಲ್ಲಿ? So direction is considered along the direction of the motion. That is, example in this case, displacement, velocity, acceleration, etc. That is direction of the vector